Hello scientists! Welcome back to another episode of Virtually Alive. Today we're going to be talking about different kinds of natural disasters.
A natural disaster is a major event caused by natural processes of the earth. Examples include floods, hurricanes, tornadoes, wildfires, volcanic eruptions, earthquakes, tsunamis, and other geologic processes. A natural disaster causes loss of life or property damage, and leaves some economic damage after it has been completed. We're going to look at some of the commonly occurring natural disasters in greater detail. To start, an earthquake is the result of a sudden release of energy in the Earth's crust that creates seismic waves. At the Earth's surface, earthquakes manifest themselves by vibration, shaking, and sometimes displacement of the ground. The Earth's surface is covered with 20 plates that move continuously and slowly past each other. When the plates squeeze or stretch, huge rocks form at their edges and the rocks shift with great force, causing an earthquake. Think of it this way. Imagine holding a pencil horizontally. If you were to apply a force to both ends of the pencil by pushing down on them, you would see the pencil bend. After enough force was applied, the pencil would break in the middle, releasing the stress you put on it. The Earth's crust acts in the same way. As the plates move, they put forces on themselves and each other. When the force is large enough, the crust is forced to break. When the break occurs, the stress is released through an earthquake. The underground point of origin of an earthquake is called the seismic focus. The point directly above the focus on the surface is called the epicenter. A tsunami is a gigantic wave or series of waves caused by an earthquake, volcanic eruptions, or landslides under the sea. Tsunami is a Japanese term for great harbor wave. Though sometimes called tidal waves, tsunamis have nothing to do with the tides. Earthquake-induced movement of the ocean floor most often generates tsunamis. Landslides, volcanic eruptions, and even meteorites can also generate them. Usually an undersea earthquake starts a tsunami's waves rolling across the ocean. If you've ever tossed a pebble into a pond, then watching ripples spread out over the surface, you've seen this principle at work. For our first activity, we are going to make a seismograph. If you have ever watched the news after an earthquake has occurred, you've probably heard the newscaster talking about how high on the Richter scale the earthquake was. The Richter scale measures intensity and places the intensity on a scale based on how destructive it was. A specific tool called the seismograph is used to measure the Richter scale. In this activity, you will be constructing your own working seismograph that you can use to make your own scale to base the intensity of vibrations on. What you need is an empty cereal box, scissors, masking tape, a fine tip marker or pen, a ruler, plastic disposable cup, hole puncher, 2 pencils, string, hot glue, and grid paper. On the front and back of the cereal box, measure 1 inch from the edge using a ruler at 2 places on each side and draw a line connecting the two. Do this for all 4 sides. Using the scissors, cut out the center square on each side so that the box is hollow. Place a piece of masking tape across the top of the box to seal it shut. On one of the pieces of cardboard which was cut out of the box, using the large open side of a plastic cup, trace a circle on one of the pieces of cardboard that you cut out. Cut out a circle, and then using the hole punch a hole through the center of the circle of cardboard, and using a pencil, punch a hole through the center of the bottom of the cup. Now, punch 2 holes through opposite sides of the top of the cup. Push the pencil through the hole in the bottom of the cup with the sharpened tip facing down and leave part of it sticking out. Glue around the pencil at the bottom of the cup to seal any leaks between the pencil and the cup and allow the glue to dry. Pour a small amount of sand into the cup so that it fills about the bottom 1 inch of the cup. Thread a piece of string through the holes on the top of the cup, wrapping them around the pencil. Thread the string through the hole in the cardboard circle and push the cardboard circle onto the eraser end of the pencil while threading the pieces of string through and glue it to the rim of the cup. Poke a hole in the center of the top of the box. Cut slits on the front and back of the box 1/2 inch up from the bottom, 2.5 inches wide, and at the very center. Thread the graph paper through the slits such that only about 1 to 2 inches is through the back. Thread the string attached to the cup through the hole in the top of the box and tie around the second pencil such that the pencil that is glued inside the cup is touching the paper. Now you can test the intensity of earthquakes you simulate yourself. Try shaking the table, jumping around near the seismograph, or anything else like that. Make predictions about what you think will cause the most vibrations without actually touching it. Another natural disaster we will look at are tornadoes. For this experiment, we will demonstrate the shape and power of a tornado. What you need to make a tornado in a jar is a glass jar with a lid, water, clear dish soap, food dye, and maybe glitter if you want. Once you have your supplies, you're ready to go. Fill your jar about 3/4 full with water and add in 3 to 5 drops of food dye depending on the size of your jar and how dark you want your water to be. Add a teaspoon of dish soap to the water. Tighten your lid. Simply hold the jar by the lid and rotate it around in a circle in a smooth, steady motion with your wrist and watch the vortex form. Notice how the suction power of the tornado was able to pick up the glitter. As you can see, in real life, tornadoes can be very dangerous as their high-speed winds can break apart buildings, knock down trees, and even toss cars into the air.
Thank you for watching. We hope you enjoyed the video and we'll see you next week. Bye!